constant coefficients. Okay, so let me first define the homogeneous differential equation. In the previous chapters, we have learned first order differential equations. Now we will learn higher order differential equations. By higher order differential equation, I mean to say that the derivative is of nth order or maybe less. So for example, here I'm saying dny by dxn. So it could be d2y by dx square, d5y by dx5, and so on. Now I have x as the independent variable, y as the dependent variable. Therefore, I have the coefficients as the function of x as the function of the independent variable. Okay, and these coefficients are just the functions of x, and we have got on the right hand side a 0, and on the left hand side we have either y or y's derivatives. Okay, so such a differential equation is called a homogeneous differential equation. On the other hand, if I have coefficients as the function of x, and then the derivative of the dependent variable and the dependent variable here. So I have, for example, let's say that we are talking about the second order differential equation. Then I'm saying that a of x, and then I have d2y by dx square and so on. And then at the end, I will have a naught of x and y is equal to, I have another function g of x. This time I do not have a 0 on the right hand side. I have a function of x again. Then I will say that this is a non-homogeneous differential equation. Okay, so this is the basic definition, and we will revisit this definition again and again in the upcoming lectures. Okay, so now let us talk about today's topic. Today's topic is when I have the coefficients here, functions of, instead of the functions of x, I have the coefficients constants. Let's say I have an of x as 1, an minus 1 of x as 3, something like that. Okay, so we will solve some questions today, and the topic name is homogeneous differential equations with constant coefficients. Okay, and from the book of ZIL, we will solve some questions from exercise 4.3. Okay, so students, let us now talk about some questions. I have solved some questions by hand so that you'll be able to understand the questions easily. Now let us say that I have a differential equation . I have a differential equation d2y by dx square minus 36y is equal to 0. This is question number 3 from exercise 4.3 of ZIL's differential equations book. Okay, now I will call the derivative an operator, and I will give it a dummy name. Okay, so I will say d by dx is equal to m. Then what do you think? Can I say that d2 by dx square is m square? Yes, I can, because this is the double operator. Okay, now I will replace d by dx by m wherever I see in this equation, and d2 by dx square by m square in this differential equation. I can see that in this differential equation, the coefficients are constants, and I have a 0 on the right hand side, and I have y's double derivative and y. So this is a homogeneous second order differential equation of constant coefficients with constant coefficients. Now I will substitute the operator as m. So my differential equation will look like m square y minus 36y. Okay, so I will now take y common, and always remember to take y common on the right hand side, because m is an operator. I have m square minus 36. This is called the characteristic equation. Now I will put m square minus 36 is equal to 0, and I will find the roots. I can see that m square is equal to 36 means that m is plus minus 6. So my solution is y. Always remember that we follow a specific rule. We say that whenever we have the roots of the given differential equation, of the characteristic equation of the differential equation, then the answer is always the complementary solution for the non-homogeneous equation, and a simple solution for the homogeneous differential equation. Y is equal to C1 e to the power the first root x plus C2 e to the power the second root x. And if I have a third order differential equation, I will have plus C3 e to the power third root, and the process will continue. So for this differential equation, it was a second order differential equation. I will have C1 e to the power minus 6x plus C2 e to the power 6x. This is the answer to the given differential equation. Let us quickly go through the differential equation again. What we did, we had a second order differential equation, homogeneous differential equation. We replaced the operator, the derivative by an operator m. Then we said m square minus 36. We simplified it, and then we said that y is equal to C1 e to the power minus 6x plus C2 e to the power 6x. This is a very easy example. Okay, now please make a note on your notebook. We will follow a specific rule. Okay, so you should memorize this rule, please. So let me just talk about the rule. This is C1 e to the power any constant number minus alpha xi. I is the complex number. Complex number, I is imaginary, like square root of -1. Okay, so C1 e to the power minus alpha xi plus C2 e to the power alpha xi. Now you will substitute e to the power minus alpha xi is equal to cos alpha x minus I sine alpha x. This is the trigonometric identity. Then e to the power alpha xi is equal to cos alpha x plus I sine alpha x. Then you will open the brackets. You will have the constants here, C1 plus C2 cos alpha x plus I C2 minus C1 sine alpha x. Then you have the coefficient C1 plus C2 as A, I C2 minus C1 as B, and then you have sine alpha x. So please remember that whenever we solve some questions in chapter number 4 and we face such a situation, we have C1 e to the power minus alpha xi plus C2 e to the power alpha xi, you can straight away write it equal to another new constant times cos alpha x plus another new constant times sine alpha x. And this constant, this I, the imaginary number, has been absorbed by this constant. All right, so this is the rule that we will be using in the other two questions. Okay, now let us talk about another question. I have here okay, let's talk about this question, students. I have a differential equation y double dash or d2 by dx squared plus 9y is equal to 0. I will now substitute the operator. I will say that d by dx is equal to m, d2 by dx square is equal to m square. I will substitute it here, m square y, okay, and plus 9y. I will take y common, and please always remember that I cannot write it like this. This is the wrong notation. I cannot write a y outside the brackets on the left hand side. I will have to write it on the right hand side. Now I'm saying that m square plus 9 is the operator on y. In this case, I'm not saying that. So this is the wrong way of writing, of taking y common. Okay, so this is the right way. Remember this, please, for the exams. Now I will simplify it. I can see that m square plus 9 means m square is equal to minus 9, m is equal to plus minus 3i. Okay, so I have C1 e to the power minus 3ix plus C2 e to the power 3ix. Okay, why? Because this is the basic procedure. Whatever the roots are, we will say y is equal to C1 first root e to the power first root x plus C2 e to the power second root x. Okay, so I have got something similar to the rule that I have just discussed with you. This step is optional. If you memorize the rule and go to the answer straight away, that is also acceptable. Okay, so I can write the final answer as y is equal to a cos 3x plus b sin 3x. Okay, so let's solve another question. This is a lengthy question, okay, and very important. 3y double dash plus 2y dash plus y is equal to 0. 3m square y d2 by dx square is m square, d by dx is m, and here we do not have any operator. So my answer is my characteristic equation. Whatever students, whatever I get here is called the characteristic equation. I have 3m square plus 2m plus 1 times y is equal to 0. I will put it equal to 0 and I will use this identity. Okay, so I have ax square plus bx plus c is equal to 0. This means that minus b plus minus root b square minus 4ac divided by 2a are the two roots for this equation. Okay, so I will put the values here, these coefficients here, and I will get this root. I have two roots now, minus 1 minus root 2 I by 3 and minus 1 plus root 2 I by 3. I will substitute these values to the standard answer. Y is equal to c1 e to the power first root x plus c2 e to the power second root x. I will take e to the power minus 3 by x common, or minus x by 3 common. I can see here it is common because exponential has got the power, so we can see that when we split it, we can write it outside the bracket. And again here, once again, I will implement the rule here that we have just learned, and this is my final answer. Now let me quickly show you the homework. You will submit the homework by Friday, so please solve question number 10, 12 and 14 and upload it on the portal. Okay, thank you so much.